Hi everyone. Today we are going to discuss about the structure of kidney. So you can see here the structure of kidney. It's a external morphology we are going to deal here. So humans have a pair of kidneys located in the abdominal region. You can see in the picture here. The right kidney is slightly lower than the left kidney because in human beings, liver is placed on the right side, which is heavier. So it will push the right kidney a little bit lower in direction. So they are asymmetrically arranged. The right one is lower, little bit lower, and the left one is little bit upper in the region. Okay, they are bean shaped. They are bean shaped. You can see here, and they are reddish in color. Kidneys are reddish brown in color, bean in shape. Okay, and each kidney gives rise to a pair of a vein and a ureter. So they give rise to ureter, which carry the urine, and they give rise to a vein which is blue in color here, and the artery enters into the kidneys, which supply blood to the kidneys. Okay, and here each kidney is covered. Here kidneys are called as retroperitoneal organs. As you have studied earlier, they are called as retroperitoneal organs because they're located outside the peritoneum, and hence they need protection. For the purpose of protection, these kidneys are covered by a fibrous connective tissue, which is called as renal capsule. We call it as renal capsule. Here you can see here. So kidneys are bean shaped and they're covered with a renal capsule. And the weight, if you take the weight of each kidney, is around 150 grams. And so this renal capsule helps it from preventing it from the injuries. It prevents our kidneys from injuries. And not only that, around the capsule, there is also a layer of fat adipose tissue, which is called as renal fascia. So each kidney is covered by a thin, tough, fibrous connective tissue called as renal capsule. And surrounding the renal capsule, there is a adipose tissue, which is called as renal fascia. And it is outer convex in surface and inner concave in surface, if you see the diagram there. And where are they located? They are located, as I told you, they are located in the abdominal region. So if you take in the center, we have a vertebral column. So at the back side, it is located on either side of the vertebral column between the 12th thoracic vertebrae and the 3rd lumbar vertebrae. So between the 12th thoracic vertebrae and 3rd lumbar vertebrae, both the kidneys are located on either side of the vertebral column. And as I told you earlier, the right kidney is usually slightly lower than the left because we have a very large liver on the right side. And if you take a rabbit, for example, in rabbit, the left kidney will be lower and the right kidney will be a little bit upper in position, because in rabbit, the stomach will be larger in size and that will occupy the left side. And there are an artery which enters the kidney through hilum, a notch present at the kidney, which at the entrance of the kidney is called a hilum. And this renal artery, it progressively enters into the kidney and divides into interlobular arteries. And these interlobular arteries then again differentiate into efferent arterioles. And these efferent arterioles, they enter into glomerular capillaries, or they form into glomerular capillaries by entering into Bowman's capsule. So after forming glomerular capillaries, they come out in the form of efferent arteriole, and these efferent arteriole, they form a network around the nephron as peritubular capillaries, and generally we call them as vasa recta. And after that, they come out in the form of interlobular vein. Within the kidney itself, they form into interlobular vein, arcuate vein, and interlobular vein, and then they come out in the form of renal vein. So as you see here in the diagram, so the blue one is a vein which is coming out, and the red one is artery which is going inside. So when this artery enters into the kidney, it divides into many number of arterioles. And those arterioles, they enter into Bowman's capsule in the form of efferent arteriole. And after that, they come out of the Bowman's capsule after forming into glomerulus, and they come out in the form of efferent arteriole. And that efferent arteriole forms into interlobular veins. And all the interlobular veins within the kidney, they join together and come out in the form of a renal vein. And that renal vein, it joins with the postcaval vein. And then from each kidney, you can see there's a tube arising, and this tube is called as ureter. And ureter is nothing but its function is only to carry the urine which is formed within the nephron, and that urine is collected in the urinary bladder. Urinary bladder is a sac-like structure, a pear-shaped sac-like structure. It is having the property of extensibility, and then it opens out an opening called as urethra. So this is the external morphology of kidney. And now if we come to the internal structure, internal morphology of the kidney here. So this is a cross section of the kidney, one single kidney it is. You can see here, it is majorly divided into two regions. The outer region is called as cortex, the inner region is called as medulla. And combined we can call it as a tissue, so we can call it as a parenchyma. And outside this cortex, it is covered by, as we have seen earlier, I told you, renal capsule that will be covering over the kidney, which is called as renal capsule. Now this cortex is nothing but it is a connective tissue. Okay, this cortex region consists of the Bowman's capsule of glomerulus and the renal tubules are present in the cortex. And then it leads into the next region, which is called the inner region of the kidney. The inner region of the kidney is nothing but called as medulla. Medulla, you can see the diagram here, it contains some 8 to 18 pyramid-like structures. And these pyramid-like structures are called as renal pyramids. And the tips of the renal pyramids, they end in the area called as renal papillae. And between the pyramids, you can see here there are columns, and these are columns are called as renal columns, or we can also call as Bertini, columns of Bertini. They are also called as columns of Bertini, into which the cortex invaginate or invades. The cortex invades between the pyramids, and the area where cortex invades, we call it as renal column, or we can also call as columns of Bertini. And here the pyramid, each pyramid ends with an area called as renal papillae, and each renal papillae leads into small groove-like structures, and these small groove-like structures are generally called as minor calyx because they're smaller in size. The diameter will be smaller, so they're called minor calyx. From minor calyx, they reach to the major calyx. From major calyx, they reach to a large conical shaped structure called as renal pelvis, and that renal pelvis opens into ureter. So this is the internal morphology of or what we can say the cross section of the kidney. So you can see here, it is having an outer covering called capsule, and then the next region is the cortex, which is reddish brown layer of tissue immediately below the capsule. And next comes the medulla. Medulla contains renal pyramids, and the renal pyramids number is almost 8 to 18. And next comes the renal papillae. The apex of each pyramid is called renal papillae, and they open into minor calyx. From minor calyx, they come to major calyx. From major calyx, they open into pelvis, and that pelvis leads into ureter, which collects after the urine. Generally, urine forms in the nephron. Finally, the urine gets collected in the pelvis, and from pelvis, it reaches to ureter, and from ureter, it goes into urinary bladder, where it is stored for a while till the process of micturition. So this is the cross section of the kidney. And next comes the most important thing is nothing but the nephron, which is the functional unit of kidney. The functional unit of the kidney is the nephron. So here you can see the diagram here. So each nephron, each kidney contains almost 1 to 2 millions of nephrons. And there are two major portions in the nephron. One is called renal corpuscle, other one is called renal tubule. You can see in the diagram here, the cup-like shape is called as Bowman's capsule. And within this Bowman's capsule, we have network of capillaries called glomerulus. And these network of capillaries are formed due to the efferent arteriole and efferent arteriole. These two, they form a network here within the cup, and we call it as glomerulus. And Bowman's capsule give rise to tube-like structures. You can see here the yellow colored tube-like structure. And these are called as renal tubules. This whole structure is called renal tubule. And this renal tubule is surrounded by a network of blood vessels. We generally call them as peritubular network. And this peritubular network, here in case of, here the U-pin, this is called U-pin, which is called loop of Henle, we call it as vasa recta. And near to PCT and VCT, we call it as peritubular network. So this is a brief note. I'll deal in detail. Now you can see here renal capsule or Malpighian body. You can see a very good picture here. This is the Bowman's capsule lined with squamous epithelium. And this is the middle one is nothing but the glomerulus, or what we call glomerular capillaries. How it is formed. The efferent arteriole enters into glomerulus, divide and redivide, and comes out in the form of efferent arteriole. You can see in the diagram here, the efferent arteriole, the diameter is larger when compared to the efferent arteriole. Okay, here the capillaries and the cells of the loops, they form into an apparatus called juxtaglomerular apparatus. Okay, and see here the glomerulus, or surrounded by a cup-like structure called glomerular capsule, or we can also call it as a Bowman's capsule. And Bowman's capsule is nothing but a double-layered structure consisting of 3 layers: outer parietal layer, middle basement membrane, and inner visceral layer. So outer parietal layer consists of squamous epithelium, and this squamous epithelium has minute pores, and those pores are called as fenestrations. Nothing but they help in the process of filtration. The filtration of urine or the filtration of blood takes place within the glomerulus. After filtration, the formed liquid is called as primary urine, and that primary urine passes through these fenestrations. And next one is the basement membrane, which is selectively permeable membrane. And then next is inner visual layer, a large nucleated cells. It's made up of large nucleated cells called as podocytes. And these podocytes bear finger-like projections known as podocells. And area between two podocells is filtration slits through which the process of filtration occurs. Okay, here is another picture. Here we can see clearly. So this is the two arterioles. They are forming into the glomerular capillaries, which help in the process of filtration, or what we call ultrafiltration of the blood takes place within this. And then the filtered primary urine comes out through Bowman's capsule and leads into renal tubules. So I think you got it. Renal corpuscles or Malpighian body. It is nothing but consists of two structures. One is the cup-like structure called as Bowman's capsule. The inner network of blood capillaries is called as glomerulus. And one important point which to be noted is the efferent arteriole. The diameter of the efferent arteriole is larger when compared to the diameter of efferent arteriole. And these 3 layers together, they combine and they form filtration membrane. We generally call it the filtration membrane. So Bowman's capsule, which is having double-layered structure, generally we call it as filtration membrane, which helps in the process of filtration. The filtration membrane is nothing but the capillaries of glomerulus and the squamous epithelium of this particular Bowman's capsule. Together they form into a membrane, which is called as filtration membrane. Okay, next is renal tubules. Renal tubules means the tube-like structures, the convoluted, the coiled tube-like structures coming out from Bowman's capsule are called as renal tubules. And we divide into 3 different structures here. One is called proximal convoluted tubule, loop of Henle, and distal convoluted tubule. And the last one is the collecting tubule. There are 4 different types of tubules here. The first one is proximal convoluted tubule. So it is called proximal because it's near to the Bowman's capsule. So we generally call it as proximal renal tubule. And it is lined with microvilli. It is lined with cuboidal epithelium, having brush-bordered cuboidal epithelium, lots of microvilli, because it is the area where selective reabsorption takes place most. After the formation of urine, generally what happens when we discuss about urine formation, there we will get to know about it. It is lined with microvilli, which helps in the reabsorption of the materials which are necessary to our body. So during urine formation, generally what happens is some of the electrolytes, some of the glucose, some amount of amino acids, and most of the water comes out through this primary urine, but it should be reabsorbed back into our body. That reabsorption, maximum reabsorption of the required elements to our body like water, glucose, amino acids takes place in PCT. So that's the reason they have microvilli, which increase the area of absorption. And next comes the loop of Henle. Loop of Henle is U-shaped middle portion of the renal tubule. It is having 2 ends, ascending limb and a descending limb. Ascending limb is thick walled and impermeable to water, while descending limb is thin walled and permeable to water. And this ascending limb and descending limb helps, it plays a very crucial role during urine formation. And that mechanism we will discuss about when we go to urine formation there, that is countercurrent mechanism. So in countercurrent mechanism, this loop of Henle plays a major role because ascending limb and is impermeable to water and descending limb is permeable to water. So this helps in maintaining a concentration gradient during the urine formation. And next comes the distal convoluted tubule. It is the last portion away from the Bowman's capsule. So we call it as distal, means away. So it is distal part of the renal tubule that leads to collecting duct. It is similar to the structure and function of PCT. As PCT do, same function here it is performed. But the major difference here is, here in PCT it is lined with cuboidal epithelium, and here also it's lined with cuboidal epithelium. The difference is microvilli are generally absent in distal convoluted tubule. And it has intercalated cells which help in permeability of some of the hormones and all. Okay, And next one is the collecting tubule. It is not part of the nephron, rather than it's a part of the kidney. And distal kind of tubules form from several nephrons empty into a collecting tubule. So all the DCTs of some of the nephrons, they combine together and they form a tube called as collecting tubule. So that collecting tubule collects the urine from many number of nephrons, several nephrons. They empty the urine into the collecting tubule, and all the collecting tubules then unite to form a primary duct that empties urine into minor calyx. Through the pyramids, they come into minor calyx. From minor calyx, they come into major calyx, and finally into renal pelvis. So this is about the structure of the nephron, which plays, it's called functional unit of kidney, which plays a major role here. And basing on the position of this, once again you can see here, this is Bowman's capsule, glomerulus, this is the proximal convolutive, and this is a U pin, which is called as loop of Henle, having two limbs, descending limb, ascending limb, and it is having a network of capillaries surrounding it. The network of capillaries surrounding the loop of Henle is called vasa recta. The network of capillaries surrounding the PCT and DCT is called as peritubular network, and then it leads to collecting duct. DCT leads into collecting duct, and from there it comes into collecting tubule. And this collecting tubule is nothing but it collects urine from many number of nephrons, and finally it opens into minor calyx. From minor calyx to major calyx, and finally into renal pelvis, and from renal pelvis the urine goes out through ureter. So this is about the nephron. In the next session we will see about how the urine is formed. And before going to next session, we'll have just we have two types of nephrons in our body. One is called cortical nephron, other one is called juxtamedullary nephron. Cortical nephron means major portion of the nephron we see in the cortex region. So then we call it as cortical nephron, whereas a major portion, that is the loop of Henle, is completely present in the medullary region. Then we call it as medullary nephron. So the majority of nephrons in our body are cortical nephrons. And here we have basically two types of nephrons. One is cortical, other one is juxtamedullary nephron, basing on the position of the loop of Henle. And here you can see the loop of Henle is very short, but here the loop of Henle is very long. Thank you so much.